Okay, hello. Here we are on circle theorems, one of the final year 10 topics from your ASK curriculum. Right, key overall bits about circle theorems. 1. Wherever you can, mark on the questions the radii. Okay, because you know as soon as you've got radii marked on, then you've got an isosceles triangle, and that's forgotten by a lot of people, and it does help you a lot of the time. Secondly, how I've set my work out during this, because I haven't really got the room to be able to write everything, I thought it's easier to just explain it. I would get half the marks if I'm lucky. You've got to get into a habit of writing, here's my angle, here's my rule, here's my angle, here's the rule I used, here's the angle, here's the rule. If you do that with this and parallel lines, you will be absolutely sorted and get full marks all the time. Okay, right, so let's go through these. So, okay, this first one here, we're using the rule the angle at the centre is double the angle at the circumference when it's subtended. Now, subtended just means it's got the same base. So, subtended, both these angles for these triangles, both have this same base here. Now, you could say subtended by the same chord or subtended by the same arc. It doesn't matter. Okay, so they've both got the same arc as the base and the same chord as the base. So that angle is double that one, 118. These are both radii, so these two angles are equal. So you just get 118, take it away from 180, divide it by 2 to get that angle of 31. Okay, this one here, you've got another rule that when you've got two triangles coming up, both subtended by the same base, okay, the same arc there, and they're both touching the circumference, they are equal. So that way you know immediately that one's 28. These are opposite angles. So if that's 104, that's 104. So 28, 104, taken from 180, and boom, you got the answer of 48. This one, I don't know if I'm making just a silly mistake, but this is a cyclic quadrilateral. It's a four-sided shape inside a circle with all four vertices touching the circumference. And in a cyclic quadrilateral, the opposite angles add up to 180. So if that's 75, to get that one, you just take it away from 180. I don't know why they've got all this extra stuff in there. Maybe there was an extra question I missed or something. Okay, so that's 105. This one here, again, very simple. Another rule is if you've got a diameter, a triangle touching the circumference will be 90 degrees always. So that's 90, that's 57, taken from 180, and you get that one as 33. You don't need this. Let's go across here. I'll save the bottom one to last, it's most complicated. Okay, this is the alternate segment theorem. So if you imagine a segment, it's like a Terrier's chocolate orange when you break it apart. If you've got a segment as the base of a triangle, then the angle here where you've got a tangent touching the circumference, that's equal to the angle at the top of the triangle. So it's an alternate segment, that's where it gets its name from. So if that's 71, that's 71, 68 and 71, taken from 180, and boom, you got 41. Remember, each time you would be setting this out as this is 71, alternate segment theorem. This is 41, angles in a triangle add up to 180, and giving your reasons every time. Okay, this one here, again, another alternate segment theorem. So this is 39. If this is 39, this is 39, because you're also using this rule here, that if you get a point and go to two tangents, then this is isosceles, and these angles here between this and the radius are equal. So you know they're both equal. So that's 39, that's 39. Take two 39s from 180 and you get x as 102. Right, now on to the hardest question. So RCB, going from R to C to B, you know that a radii touching a tangent is at 90 degrees. It's this rule here. And so this is 90. So you take 33 from 90 and you'll get this angle in here, RCB, which is 57. Now it wants angle ABC, A to B to C, so this angle here. Now again, cyclic quadrilateral like up above, these 4 points all touching the circumference of a circle. So you know these two opposite angles are adding up to 180. So take 137 from 180, you get 43. Okay, so this angle ABC, I'll write that in now, is 43. Now the last one, you have to calculate nearly every angle, I think. So O to A to D. O to A to D. So it's this whole angle in here. Well, let's start by getting 43 here. We know that the angle at the centre is twice the angle of a circumference when they're subtended by the same chord or arc. So we can write that in as 86, and you would have been writing all those lovely words as explanation. These are both radii, so this is an isosceles triangle. So these two angles are equal, so we take 86 from 180 to get 94, divide that by 2, and we get these as 47. So both of these are 47. Now, we also know, now it looks here like you'd want to say, oh, both these angles are equal. Don't make that assumption. Never assume in circle theorems. Always just use the rules. Here we've got a radii touching a tangent, so we know this side is 90 degrees. So 47 and 24 is 71. So we take 71 from 90 and we get this little angle in here as 19. Now if that angle's 19, this angle's 137, then the angle we want is 180 minus 19 minus 137. Okay? So, I don't know, you do that, add 137 and 19 together to get 147, 156, and then take 180 minus 156, which is obviously going to be 24. So that angle is 24. Yay. Okay, so key points of circle theorems. Make sure you explain absolutely everything. Here's my angle, here's the rule I used. Here's my angle, here's the rule I used. Go simple, mark on radii, like we did in this question, like we did in this question. Radii always help you. And just show you're working. Right, bye.